Just before the break, we introduced this idea of gravity and acceleration due to gravity and how these problems involving falling objects or objects rising up into the sky under the influence of just gravity are just like any other group B problem, in which we can use those equations. A is equal to delta V over delta T, Vf squared is equal to Vi squared plus 2AD, and so on. But in each of those problems, we had one piece of information given to us that wasn't overtly stated to us. It was a read between the lines piece of information. What was that? In every problem where it's only gravity acting, the object is either rising up into the sky or falling back down. What was that one piece of information that's always given to us? Good, the acceleration. And what was the value of that acceleration? Good, negative 9.81 meters per second squared. Now, that's when the object is falling, right? What about when the object is rising? What's the acceleration then? Negative 9.81 or positive 9.81? Why negative 9.81 when the object is rising? How can it be negative when the object is falling, but yet negative at the same time when the object is rising up into the air? Yep. Good. Think of it that way. Gravity. We're going to talk in next unit about forces, but you guys have a basic grasp of what a force is now, even though we haven't learned about it, right? You guys learned about it probably in grade 6. A force is a push or a pull. Gravity pulls things down, and it pulls things down whether the object is falling down or whether the object is rising up. The force of gravity is pulling down. And if the force is pulling down, then the acceleration has got to be downwards as well. Bottom line is this. Whenever you have an acceleration that is, or whenever you have an object that is speeding up in the negative direction, in other words, speeding up going down, we make it a negative acceleration. Similarly, when we have an object that is slowing down in a positive direction to the right or upwards or to the north or whatever, then we make it a negative acceleration. So anytime you're dealing with one of these gravity problems, treat it just like the other problems that we've done ad nauseum, except that A won't be a random number. Okay, A will be negative 9.81 meters per second squared. Make sense? All right, let's get right back into it then. We had 3 questions for homework. I won't take a walk around and see if you have these done. We'll get back to that tomorrow again. I want to take a look at all 1 or 2 or all 3 of these questions, depending upon what we need to go over here. Any issues with question number 1 on this page, 58? Number 2? 2, okay. What about number 3? Okay, 3 as well. So we'll go over 2 and 3 here. And I'm glad you guys asked me for 2 and 3 actually, because there's a bit of a difference between 2 and 3 that I want you to kind of notice if you haven't noticed it already. Question 2 says, having scored a touchdown, a football player spikes the ball in the end zone, so throws the ball straight down in the end zone. The ball was thrown down with an initial velocity of 2 meters per second from height of 1.75 meters. How long is it in the air for? So listen, it's thrown downward at 2 meters per second. That doesn't mean it travels at 2 meters per second the whole way down. It speeds up as it's falling down. It doesn't mean its velocity 2 seconds after it's released is 2 meters per second. It means at the moment it leaves this football player's hand, it's moving downward at 2 meters per second. Every moment after that, it's going faster and faster and faster as it goes down towards the ground. Let's figure out how long it was in the air, how long, the time that it's traveling for. Okay, let's write down some givens here for this question. By the way, is this a group A or group B? We can't forget about that. It's because we're dealing with gravity now. We can't forget about group A or group B. Which is it? Sam? It's group B. Good. It's group B. Group B means that it's accelerating, right? Clearly, this is accelerating. Okay, we got a speed here, a velocity of 2 meters per second, but after it's released, it accelerates. And that's the real problem at hand here, is after it's released. Okay, what do we got here? 2.0 meters per second. That's going to be a V, right? Is it going to be VI or VF? Yep, VI. VI is 2 meters per second, right? What do we got here? A height of 1.75 meters. We don't really have a variable in physics yet that's called height. You will later on, but right now we haven't seen something like that, right? So what are we going to call this? Not height, but rather, so what are we going to call that? Yeah, let's call it displacement. But it's downward, right? Because the ball ends up below where it started, right? So the displacement will be a negative value, right? Make sense? We're going to make it negative 1.75 meters. Is that it? What about, do we have VF here? What's the speed of the ball when it hits the ground? 0? Anybody agree with that? Yes? VF is 0 meters per second. We're looking for the time that it's in the air. Is there anything else we have given to us here? Good. The acceleration is negative 9.81 meters per second squared. All right. Now we've got our givens written down. Be careful before you write too much here because there's 2 mistakes here. 2 mistakes in our givens here. Anybody spell one of them? Good. VI is negative because it's thrown downwards, right? If we were talking about initial speed, it doesn't really matter whether it's up or down. But if we're talking about velocity, we need a direction. And since it's thrown downward, we're going to make it negative. Now, what's the other mistake? Interesting. Yeah, Luca? Well, forget about the ball bouncing. Okay, because in the end, we're looking at just the trip down, not the trip down and then bounce, 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 bounce. Okay, the problem ends when this hits the ground. So it doesn't matter if it bounces 3 times afterwards or not. The final velocity at the end of this problem, where this problem ends, is when it hits the ground. Anyone else have a little theory here? It is still the final velocity. It's not 0. It's not 0. Why isn't it 0? We don't know what the value of VF is. It's not 0. It is moving when it hits the ground. We just did a little demonstration where we pretended that we were going to drop a hole puncher on Brie. We're not going to do that because it would hurt. But why would it hurt? Not because the hole puncher wasn't moving. If I drop the hole puncher, it's moving when it hits. That's why it hurts. So VF of the hole puncher would not be 0. VF of the ball isn't 0 either. Now, after it bounces a few times, what is it? I don't know. I don't care. The problem at hand is the fall of the ball. At the end of this fall, it's moving. How fast? Don't know. Doesn't really matter right now. We just know it's not 0. So we can't write down VF as equal to 0. Okay, that's all we got here. Any suggestions here? Any suggestions it might be helpful to solve this problem? Remember, it's a Group B problem. You found VF. Okay, interesting. Okay, I might go back to that here. Give me a second. Is there an equation that allows us to find T right away without finding VF? There is one, and a number of people have asked me about this, actually. It's VIT plus 1/2 AT squared. I've got D, I've got VI, I've got A. The only thing I don't have here is T. Now that's a problem. To solve for T, if VI is not 0, because it requires us to use something called the quadratic equation, which some of you haven't even learned about yet. If you're comfortable with the quadratic equation, you can make it work here, then go ahead, be my guest. But I can promise you, you'll never have a question where you need to use the quadratic equation. In other words, although this equation is the only one that will allow us to find T right away, it's probably not the one to go with. How'd you find final velocity? Okay, so that's actually going to find its final speed, but we can put the negative on it because we know it's going to be a downward velocity, right? VF is the square root of VI squared. I want to say 2.0 squared plus 2 times neg 9.81 times negative 1.75. Is that right? Can I put a negative 2 there? Why not? Why not? Let me preempt you. I know somebody's thinking, oh, because when you square it, it becomes positive anyways, right? Well, it does. But that's not why you don't put the negative there. Let's read this equation. VF squared, final speed squared, is equal to VI squared, initial speed squared. What's the initial speed? What's the initial velocity? -2. What's the initial speed? 2. There's no negative with the initial speed, right? That's why we don't put in -2 there. What did you get for that, for VF? 6.1915 meters per second. So that's the final speed. We can say the final velocity is -6.1915 meters per second. Good. It's not what we're looking for. I don't care. Even if this doesn't help me, I haven't done anything wrong here. I've solved for something that's correct. It's just not what I'm looking for. Odds are, though, it is going to help me, right? Odds are. Because I've got one more piece of information than I had before. All right. Now, in addition to VI and V and A, now I have VF. Maybe that's going to help me solve T. Any suggestions? Right? Okay. Acceleration is delta V over delta T. Solving for T. So the T goes up by multiplying. The A goes down by dividing. It becomes delta V over A. Delta V is VF minus VI. It's -6.1915 minus, oh, be careful here. What was VI? 2 over -9.81. That's wrong too. What have I done wrong there? The equation is correct. What you told me is right. What have I done wrong? Yeah, just because it was subtract 2 doesn't mean I've put in the negative for the 2. It's subtract -2, which means -6.19. It's like -6.19 plus 2, right? Which becomes -4.1915 over -9.81. Do the math on that one, and it should work out to be, I assume, 0.43. Notice it's negative over a negative because it's a positive. Positive 0.43 seconds. How many people got that one? Anybody do it with the quadratic equation? Yes? Okay. Everybody else do it that way, or did you come up with another way? Anybody do it a different way than what we have up on the board? Okay, so it's a two-stepper, right? Big deal, really, right? It's just means that solve for something and then use it. Okay, if you ever find yourself in this jam, it's a test day, and you get this problem, and it's like, I can't figure this out. I can't for the life of me figure out what equation that I can use to find delta T. Don't worry about it. Pick one. You're either going to get no answer and you're going to pick another one, or you're going to get an answer like VF and then you're going to use that. Okay? It has to work for you. That's how much it has to work for you. I'm throwing my pen. That's how much it has to work for you. Just don't be afraid to try. Okay? Just take a risk and try something. Okay, let's try number 3 here now. This one says, an elevator moving downward at 4 experiences an upward acceleration of 2 for 1.8 seconds. What's the velocity at the end of the acceleration? How far has it traveled? Wait a second. Is this a gravity question? It isn't, is it? They're telling us the acceleration is not negative 9.81. In other words, there's something other than gravity acting here. I'm not sure why they put this question where they did, but in the end, I assigned it because I kind of like it, actually. It's a test for us, right? We're talking about, on Friday before the break, we're talking about gravity. I do an example with A being equal to negative 9.81. We just do 2 questions where A is negative 9.81. What's the temptation when we see question 3? To blindly make A negative 9.81. But we got to read the question. It doesn't tell us that it's negative 9.81. In fact, it tells us just the opposite. It tells us that there's something other than gravity acting here. because of different acceleration. That's okay. That's okay. It just becomes like one of our other problems that we've done a million times before gravity. We have VI is -4. Negative because it's moving downwards. We have A of +2. Hey, does that mean it's moving upwards? No, it says it's moving downwards. How can A be upwards? How can acceleration be upwards if it's moving downwards? The look of bewilderment on our faces. How can it be moving downward and be accelerating upward? It's braking, yeah. Look, if it's moving down and slowing down in the downward direction, remember gravity is speeding up in the negative direction? It's a negative acceleration. If it's slowing down in the downward direction, it's a positive or an upward acceleration. It doesn't have to be moving upwards to accelerate up. It can be moving downward and slowing down. That's still upward acceleration. So we're going to make A +2. My time interval is 1.80 seconds. And we're looking for VF here. Okay, I'm going to go A is equal to delta V over delta T. And I'm going to rearrange that to solve for delta V. T goes up by multiplying. A times T. 2 times 1.8 is 3.6 meters per second. Hey, that's not the answer. That's not the answer. So what do I do? What do I do? Jared, what do I do here? I've got delta V, 3.6 meters per second. I'm looking for VF. It feels like I'm close here, right? Yeah, we just did. Yeah, we just used the group B equation. Can you help me out there? Oh, don't guess. You know this. Yeah, that's not a guess. You knew that. Right? Delta V is VF minus VI. We know what VI is. Look, we know what delta V is. So it becomes 3.6 equals VF minus -4. Take that over to the other side. This is VF plus 4, right? Let's take it over to the other side by subtracting. It becomes VF is -0.40. So it was moving downward at 3.6. Now it's moving downward at 0.4. Why? Because it's slowing down. Because we have an upward acceleration. Okay. What about the displacement? This is kind of the easy part now, right? VI is, what was VI? -4 at the time. Oh, we don't have time, dude. Oh, yes, we do. 1.8. +2 for the acceleration. Okay, we don't even have to rearrange it. Let's do the math on this one. It should work out to be 3.96 meters. Actually, it should work out to be -3.96 meters. That's the displacement. The distance traveled would be positive. Either one. Good. Any questions on it? Either of those questions? Anything else? Since we're so good at those questions, let's try another one here, okay? Page 59. This is how to brighten it up a little bit, hey? Like, you know, it's first day back, kind of tired, don't want to do more problems. Hey, it's a clown. It's happy. It's a clown. Throws the ball upwards at 10 meters per second. We want to find the maximum height that the ball reaches above its launch height and the time that it takes to do that. There doesn't seem to be much given to me in this question. VI is 10 meters per second, and it's positive because it's upwards. Do we know what A is here, the acceleration? Yeah, it's negative 9.1. Even though the object is moving upwards, it's still slowing down in the upward direction. So we're going to make it negative 9.81 meters per second squared. Everything's good so far. Oh. What else? Do we have anything else, or do we have to just look at what we got written down there right now and find what we're looking for? Oh, interesting. Interesting. So let's draw this out here. Okay, you're throwing it upwards from ground level at 10 meters per second. What happens is that ball goes up into the air. What happens to it as it goes up into the air, Sam? It slows down. Slows down, slows down, slows down, slows down, and stops. Momentarily stops. For an instant, it stops. And then what happens? It speeds up in the downward direction. If we only analyze the upward trip, if we only analyze to this point right here, to its max height, and that's really what we're looking for is the max height, right? Then what's VF there? Nathan, what's VF? 0. Now, if we're analyzing the whole trip up and down, VF isn't 0. But the trip up, VF is 0. That's a big deal. Okay, that's a big deal to recognize that. We're looking for how high up it goes, its displacement. We're also looking for the time here. Okay, what's the challenging part about this question? Oh, we're done it. We're done the challenging part. Okay? It's recognizing that VF is equal to 0. You don't catch that, you're not going to get this question right. Yep. Okay, good question. Good question. Why wouldn't, if you didn't hear that, why wouldn't VI be 0? That's a good question. When it's in his hand, okay, just sitting there in his hand, it's not moving. Then when he throws it, obviously it's moving at 10 meters per second. But that's after he throws it, right? Why wouldn't VI be 0 as it's sitting in his hand? Here's why. The event of throwing the ball is one problem. That's something happening. And then as the ball goes up into the air and rises and slows down and stops, that's another problem. That's a different problem. So really you got two problems there. Leaving the hand, okay, the ball leaving the hand, one problem. The ball going up into the air, that's another problem. Okay? It's so important that you would consider that two problems that we're going to draw it as a little exclamation mark there. That's how important that is. Okay? The ball leaves his hand. The ball goes up into the air. Two problems. So in the problem of the ball being thrown by the guy, by the clown, VI would be 0. But that's not the problem we're looking at here. Okay, the problem we're looking at is after it leaves his hand to the time that it stops at its max height. So after it leaves his hand, we'd say VI would be 10. Now, in the first problem again, when he throws it, VI would be 0, VF would be 10. As it rises up into the air, VI would be 10, and VF would be 0. Does that make sense? So you got to look at, what am I really analyzing? What part of the problem am I really analyzing there? When it's in his hand, it's not just gravity, right? Then it is just gravity, so two problems. Okay, let's find D. What do you want to do to find D here? Easy part, right? Okay, let's go back to our group B equations. Let's go VF squared is equal to VI squared plus 2A times D. Take the VI squared over by subtracting. Take the 2A over by dividing. And sub in your numbers and solve. 0 squared minus 10 squared over 2 times neg 9.81. We got negative 100 divided by negative 19.62. It's going to be about 5.1-ish. Somebody solve for that, make sure. We're going to say it's positive 5.1, actually. Now, the time that it takes to do that, probably the best thing to do there is A is equal to delta V over delta T. T goes up, A goes down. Delta V is 0 minus 10 over negative 9.81, which is about I'm going to say 1.1 seconds. Somebody check that one as well. Yeah, listen, once we got our givens all written down, not very hard, right? At least if you were able to do the other group B problems, this isn't very hard. We just got to catch a couple of things. One is negative 9.81. And the second thing we got to catch, VF is 0. And we got to notice, obviously, that VI isn't 0. Unless we're analyzing the throwing motion as opposed to the gravity thing, right? How about you try this question then, page 59. See what you can do with that. We'll take a look at it in 5 to 7 minutes. All right, this one says the slingshot drops riders 27 meters from rest before slowing them down to a stop. So here you are, way up in the air, okay, you're attached to something, obviously, and then you're falling 27 meters. You're free falling 27 meters, and then you begin to slow down. So there's another phase now. This is the throwing it up, okay, out of your hand. Okay, the hand problem being one problem, and then the rising up into the air being a separate problem. Two separate problems here. There's the falling, the free falling under the influence of just gravity, and then there's the whatever it is that slows it down. Okay, and now how far does it go while it's slowing down? I don't know. Okay, but that's not the question I'm trying to solve here, so it doesn't really matter. All right, what do we have for the blue problem here? Well, we know that it starts at rest, so we're going to say VI is equal to 0. We're going to say the displacement is negative 27, and we're going to say that A is negative 9.81 meters per second squared. Let's say VF squared is equal to VI squared plus 2AD. Now this one's a little bit easier to rearrange because VI is 0, right? We can cross it off if we want. So VF becomes the square root of 2 times A times D. The square root of 2 times neg 9.81 times the displacement of negative 27. Do the math there. VF works out to be 23 meters per second. Should it be negative 23 because it's downwards, right? What have I just solved for there? The final speed, and speed doesn't have a sign with it, right? So it's 23. If we wanted the final velocity, then it would be negative 23. Hey, what if I went to analyze the green problem now as it's slowing down? Okay, so it free falls for 27 meters, and then it slows down. What about the and then it slows down part of the problem? Do we have any information for that? We can't solve it because we don't have enough information, but do we have anything here? Yep. Good. VI would be 23 meters per second, right? Yeah, A wouldn't be 9.81. We don't know what it would be, but it wouldn't be negative 9.81. The F would be 0, by the way, right? It would start at 23 and then slow down to a stop. So that's all we have is VI and VF. All right. I got one more for you here. And that's the last time you have to really listen to me here today. Boy, they like the clowns here. I thought for a second it was the same question, but it's not, eh? This one says, clown throws the ball upward at 10. What's the time that it takes the ball to return to the clown's hand from the maximum height? And what's the ball's final velocity? So clown throws the ball up. Slows down, slows down, slows down, stops. Goes back down, back down, back down, back down. We want to find the final velocity right there, and we want to find out the time that it takes to fall. No. Yes, from the maximum height down to the bottom. Anything else we have there? Oh, you better get this. You better get this one. Yeah, is what? Good. Good. Just gravity that's acting here, right? Does anybody want to tell me how to do A or B? I don't care what order it is, by the way. If you can get B before you get A, that's fine. If you get A first, that's fine too. Anybody have something, an idea for A or for B? Yeah. Okay, it would be, yeah. Yeah. The displacement going up would be the same as the displacement going down. So you could find D going up, sure. Although that's not what you're looking for, right? The displacement. Yeah, that's right. It's something else. Yep. I've always told you that, right? If you can get something, it doesn't matter if it's what you're looking for, because it's probably going to be helpful to you. Is there a way to find one of these directly, though? So what are you solving for there? Okay, but we don't know what the displacement is, right? But you could get it, the displacement up and then the displacement down. Let's find a shortcut for this. Let's think about this for a second. If it starts at 10 meters per second upwards, then it slows down at 9.81 and stops, and then it speeds up at 9.81, the same acceleration over the same distance, then what's the final velocity going to be? Same as it started with, right? You can't slow down at one rate and then speed up at the same rate over the same distance and not get the same velocity as you started with. So we could say right away VF here would be negative 10 meters per second. Now why don't we say for the first part of the problem, for A is equal to delta V over delta T. And delta V would be VF minus VI. So it would be negative 10. That's the final velocity on the trip down, minus 0 over negative 9.81. That's at 1.1 seconds. 1.02. Should be 3 digits because of the 9.81, right? Guys, not the only way to solve the problem. A couple guys come up with another way to solve the problem. Found delta D going upwards. Recognize that it's the same value as delta D going downwards. VF squared is equal to VI squared plus 2. That's fine. Okay, this way's a bit quicker, I think, but no better. Okay. Always options, right? Okay, yeah, no, you're right. On the last question, you found the displacement, I think, right? The other clown question. Yeah, yeah. So yeah, for sure, you could use it if that happened. You could use it on a test. Yeah, you're right. That's unlikely to happen. But we didn't have to use that the way we did this just now, right? Okay. Here's one more. All right. I got some questions for you to work on, page 63 here. I got some good news and I got some bad news. What do you want first? You want the bad news? Okay. There are 16 questions on this page. That's the bad news. The good news is you don't have to do them all. Okay, write down these questions that you have to do, please. Page 63. Number 2 to 16. So let's get a head start on those, guys. There's 15 minutes left in class. You can get a good head start on those actually, and not have a ton of homework tonight. Okay, 2 to 16 on page 63.